Hi coders, CS Time Channel here, and this video discuss about how to delete a node in the middle of a doubly linked list. If you wish to delete a node from a doubly linked list, there are two possible conditions of your doubly linked list. The first condition is when the list is empty. The second condition is when the list is not empty. When the list is not empty, there are also two possible situations. The first one, when the list has only one node, and then the second one, when the list has many nodes. Let's see the logic. When your doubly linked list is empty, your doubly linked list will look like this. The head pointer and the tail pointer point to the null. So if you wish to delete a node from the doubly linked list in this situation, then your program should throw an exception. When your list has one node, then your doubly linked list will look like this. The head pointer and the tail pointer point to the same node. And if you wish to delete a node from the doubly linked list in this situation, then you should instruct the head pointers to point to the null and instruct the tail pointer to also point to null. After the deletion, your doubly linked list will look like this. In the situation when my doubly linked list has many nodes, then my doubly linked list will look like this. The head pointer and the tail pointer point to a different node. And if I wish to delete data, say B here, then my program should compare my delete to the node.data, and my program should traverse from the first node all the way to the last node. To do this, I need the help of another pointer. Here, I use temp1 that I assign to point to the same node pointed by head. So the visualization look like this. If I wish to delete B, then I will compare the temp.data, which is A here, to the delete, which is B here. If the data is the same, then we will delete the first node. I discussed how to delete the first node in the previous video. If the delete is not the same with the first node, then I have to instruct the temp1 traverse to the next node. To do that, I will have to do the checking. If temp1.data not equal to delete, then I should instruct my temp1 to traverse to the next node. Temp1 equal to temp1.next. By giving this instruction, the visualization will look like this. As my temp1 traverses to the next node, I need the help of another pointer. Here, I use temp2. Temp2 will point to the previous temp1 node. The purpose is when I wish to delete B, I can instruct the next pointer of A to point to the C node. So the instruction for temp2 will be temp2 equal to temp1. If temp1 data still not equal to the delete, then temp1 pointer must move to the next node, and as temp1 move to the next node, temp2 will move to the following node, which is the previous node pointed by temp1. So the visualization will look like this. Since we will keep repeating this instruction, so this instruction will be wrapped under while loop like this. Now let's see how to delete the B. Temp1 holding A. So temp1.data will be compared to B. If it's not equal, then temp2 will occupy temp1, which is stay there, and then temp1 will go to the next temp1.next, like that. And now we check again. Temp1.data, which is B, compare it to the delete, which is B. Since it is the same, now we find the data to be deleted, which is in this node. To delete this node, we have to instruct the next pointer belong to the A to point to the node that consists C. To do that, we can give this instruction. temp2.next, which is here, equal to temp1.next. By giving this instruction, our visualization will look like this. After that, we will pay attention to the previous pointer belong to C. To access this, we can give this instruction. temp1.next temp1.next.previous, we instruct it to point to temp1.previous. By giving this instruction, the previous pointer belong to the node that has C will point to the node that has A, like this. Now pay attention to the node that has B. The node that has B still attached to C and A. So we need to untie this. We need to instruct this to point to null. So the instruction is temp1.next point to null. By giving this instruction, the visualization will look like this. There's one more job to do, which is the previous pointer. We can give this instruction temp1.previous equal to null. By giving this instruction, the previous pointer will look like this. Now our doubly linked list will look like this. Let's see the Java implementation. In this video, I'm still using the program that I used in the previous videos. So in the previous video, we discussed about how to delete a node from the beginning of a doubly linked list or delete first. And we also discussed about how to delete a node from the last of a doubly linked list or delete last. Before we write a method to delete a node from the middle of a doubly linked list, we will run this program to see the result. So in the previous program, the program can do insertion in the beginning. Here is the result. And then the program can do insertion in the middle. So this is the result. And the program can do deletion of the first node. Previously was like this, and after delete first, it looks like this. The A has been deleted. And then the program can do deletion of the last node. Previously was like this, and then after we run the delete last, the last node has been deleted. Now let's write the method how to delete a node from the middle of the doubly linked list. The same with the delete last, I will declare my method as public list node delete middle. Since we want to delete in the middle, then we need to know what data to delete. Parameter will be here, data. Since we have only data, then we will need to create the node for the data. So I declare it as list node, and then I use delete, and then new list node, this data. Put it there. Based on concept explanation that I explained just now, the first situation when the doubly linked list is empty, so we will just call empty method because we have empty method here, this one. If it's empty, which means the head and tail point to null, we want to throw an exception. So we will throw an exception here to avoid error in our program. Another situation when our list consists of one node or many nodes. To do that, we need the help of another pointer, which is temp1 and temp2. Temp1, we instruct it to point to head. We can also instruct the temp2 to point to head. If it's only have one node, then it means head equal to tail. It means the doubly linked list only has one node. Then it means we can instruct the head to point to null, and then the tail also point to null. Another situation when the doubly linked list has many nodes. When the doubly linked list has many nodes, there's possibility that our node is in the middle. So like in our explanation just now, we need a looping to traverse the doubly linked list from the beginning of the node until the last node. So we will compare whether temp1.data not equal to delete.data. If it's not equal to the delete.data, then we will tell the temp2 to point to temp1. Now the temp1 can move to the next node. Temp1 is temp1.next. When our data is found, we need to quit from the looping. Now we can link our temp2 next pointer to point to temp1.next because temp1 will be deleted, and then temp2.next.previous to point to temp1.previous. If you are still confused, please go back to the visualization just now. And then temp1.next, we want to untie the node to point to null, and then temp1.previous point to null. We are ready to delete the temp1. Let's see one more time before we run it. So at first, we send the data that you want to delete it. We create the node for this data. That is why I declare delete as list node. and then the data, we assign the data from this parameter. The first situation is when the doubly linked list is empty and you try to delete it. To avoid error, we give exception. And then the second situation, when our doubly linked list consists of one node, so it means head and tail point to the same node. Because of that, we instruct the head to point to null and the tail point to null. Otherwise, means our doubly linked list has many nodes. If our doubly linked list has many nodes, then we need to instruct the temp1 to traverse from the beginning until the end of the node. So we will compare the temp1.data. If it's not equal to the delete.data, we will tell the temp1 to keep on moving to the following node. As temp1 moves to the next node, temp2 also moves to the previous node pointed by temp1. Once we find the node that consists that data, it's time for us to delete. To do that, you assign the next pointer belong to temp2 to point to the node pointed by temp1.next. And then we need to instruct the previous pointer belong to the node pointed by temp1 to point to temp1.previous. And then after that, we need to remove the link belong to the node that you wish to delete, which is under temp1. So the instruction is instruct the next to point to null and then the previous point to null. So temp1 will be disconnected from other nodes, which is safe to delete. Let's run it. So I will just comment this one first, so we can focus on the delete middle method. So let's run it first before we call it. Here is the doubly linked list. So say for example, I want to delete C, then okay, and then I will run it. Then let's see the result. Previously, this is our doubly linked list, and I delete C here according to my program, and then C is deleted. Now A point to D. And if I want to try one more time, for example, I want to delete D, just to check our delete middle method, and then run it. It works properly. So the first one, I delete C. Second one, I delete D. So I delete C and D. If you learned something from this video, please subscribe and like for more videos. Thanks for watching.